All right, so in this video, we're going over primes and then how to do greatest common factor and least common multiple. So these are the greatest common factor and least common multiple. Those are commonly missed questions on the exam. So let's go over it and make sure we understand stuff. So to have any chance at the greatest common factor, least common multiple questions, we need to be able to know how to do, first of all, just how to find prime numbers, and that can be a question in and of itself, and then also how to find prime factors. So let's go over each of those. Okay, so our rule for a prime number is an integer, meaning whole number, greater than 1 that has no factors other than 1 and itself. No even number can be prime except for 2. All even numbers are divisible by 2 and therefore can't be prime. Okay, so if we put out some examples here, so we got 2, let's go with a 9, let's go with a 17. What else? What's others? Number 49. Okay, and seeing, can you tell which of these are prime, which ones are not? So we said 2 is prime, right? 2 is always prime, and it's the only even number that's prime, right? We don't have any other even numbers on this list. As we go next to 9, right? And so we're thinking, okay, you got 1, you got 9. Is there any two numbers that you can multiply together besides 1 and 9 that get us to 9? Those, yes, 3 and 3. Okay, so because 3 times 3 is 9, 9 is not prime. Okay, we'll go ahead and cross out 9 for now. Okay, so 9 is not prime. And then what about 17? Okay, so kind of doing the same thing. All right, I got 1, 17. Are there any two numbers besides just 1 and 17 that we can multiply together to get 17? Any other two integers? And the answer is no. And so because of that, 17 is prime. Okay, so 17 is a good one. And then what about 49? We got 1, we got 49. And what about these guys? 7 and 7. 7 times 7 is 49, right? And so because of that, 49 not prime. Okay, and as we're getting into prime factors, we really aren't going way up there to 49 like that. It's usually going to be questions about numbers like 2 and 3 and 4 and 6, numbers like that. So those I just said, 2's prime always, right? 3's prime, 4's not, 6 is not. Anyways, so that's our starting point. And you may just get a question just on primes by themselves, like which of the following numbers are prime. And so because of that, we want to be familiar with that. That's a little bit more low-hanging fruit. Okay, so next we'll look at prime factors. Okay, so we'll do an example. So what if it said for the number 24, find all the prime factors of 24. So the way we go about doing that is, first of all, we just find all the factors. Okay, so you start with 1 and then whatever the actual number is, 24. Okay, because 1 times 24 is 24. And then we sort of go 2, and we'll go 12, right? 2 times 12 is 24. So that's a good one. 3 times what is 24? 8, right? 3, 8. And sometimes I don't give myself enough room. 4 and 6. And 5 doesn't work, right? 5 times 5 is 25, but 5 times there's not an integer that works to get to 24. And so those are all our factors. Okay, so those are the factors of 24. And now our question is, which of these numbers are prime? Okay, so we kind of go through what we just did at the beginning. 2 is a prime number. We like that one. Okay, because we said 2 is always prime, right? 3 is a prime number, right? Because 1 times 3 is 3, but there's no other integer that we can multiply to get 3. Okay, none of the even numbers work, right? 4, no. 6, no. 8, no. 12, no. 24, no. Okay, so all we have The only prime numbers we have are 2 and 3. Okay, and then when we're trying to answer this question, is we need to be able to multiply these some 2's and 3's together to get to 24. Okay, and so what we'll do is 2 times 2 is 4 times 2 is 8, and finally we have our 3 times 3 is 24, because 8 times 3 is 24, and so the prime factors of 24 are this. That'll be the actual answer. 2, 2, 2, and 3. Okay, so hopefully you guys are still with me. Like, hopefully that made sense, right? And that we learned how to find a prime number, and then we learned how to do the factoring part. Okay, let's give ourselves some room. And so if we can do that, jumping into greatest common factor and least common multiple isn't too big of a jump just from that. If we just know those two things, like, those are definitely possible questions on the exam. Okay, so we'll do greatest common factor first. So just from understand what it means when they are asking you for greatest common factor. Greatest common factor is the largest number that divides evenly into all of the numbers. To find the greatest common factor between numbers, take each number and write its prime factorization. Then identify the factors common to each of the numbers and multiply those common factors together. Okay, so what did they just say? Okay, so what you're going to be given is, it's going to say, like, what is the greatest common factor of two numbers? And it'll be like, so here we're going to do 40. We will do 40 and 140. Okay, and so what you're going to do, and we'll do this step by step, is first we're going to find the prime factor. So we'll do 40 first. Okay, and then we'll do 140 second. And, whoops, come on, semicolon. So we're going to do 40 and 140. Okay, and then we're going to find which ones they share. Okay, which prime factors they share. All right, so we start off 1, kind of like we did with 24 just a second ago, yeah? 1 and 40, okay? And then 2 times 20 is 40, okay? 3 times 13 is 39, but there isn't a number that gets us to 40, so we'll skip over 3. 4 and 10, 4 times 10 is 40. 5 and 8, 5 times 8 is 40. And so if multiplying these numbers together and getting to 40 is challenging for you, is you really have to go back to kind of like multiplication tables, so that you're comfortable with this, because otherwise this will just be impossible, right? 6 times 6 is 36. 6 times 7 is 42, right? So we don't have a number there, and so that's going to be our list. Okay, and then again, trying to remember, 2 is always prime, yes. Even numbers are never prime, so that 5 looks good to me, but 8's even, all these are even, 4's even, so we just have a 2 and a 5. Yeah? All right, and we go 140. Okay, that's a big one. 1, so we'll go way over here. 140. Okay. 2 times 70 makes 140. Let's see here. 3 and 140, no, that's not going to work. 4 times 35 is 140. And if I do the math here faster than what you can do in your head, that's fine. Just hit the pause button and think it out. Let's see here. 5 works out, I believe. 5 times 28, I believe, is 140. And let's see here. 7 times 20, right? 7 times 2 is 14. Okay. So those are the factors of 140. And again, 2 we like, 5 we like, 7 we like. Okay. Now, we've done all of the hard work, and now we just have to find which ones do they have in common, right? So we can see there's a 2 here, and there's a 2 up here for 40. 2 is a real common one. It's a real common factor, right? Real common prime factor. So 2 we're happy with, and then up here we see a 5, right? For 40. We see a 5 here for 140. So 5 we're also happy with. Okay. So we can see both of those working. The 7 that we have works for 140, but it doesn't work for 40, so no good. Right? And so prime factors of 140 equal 2, 2, 5, and 7. Both share 2, 2, and 5. Okay? So the way that we go about doing that, I forgot one of my 2's because we got it in both, yeah? 2, 2, and 5. Right? And so then what we're going to end up doing is 2, up a little bit, times 2, times 5. 2 times 2 is 4. 4 times 5 is 20. There we go. That's going to be the greatest common factor of 40 and 140. Okay, and if you wanted to just sort of think about it, so it's the greatest number that is just divisible into both 40 and 140. That's what they're asking you, right? So 40 divided by 20 is 2. 140 divided by 20 is 7. Okay, and that works. There's not a number greater than 20 where we can get there, right? And so you can just sort of think it out like that, right? So if we had just done, like down here, if we had just done like 2 times 5, right? And we said, okay, 10 is, so 10 is it is a factor of both 40 and 140, right? 40 divided by 10 is 4. 140 divided by 10 is 14, but it's not the greatest common factor. There's a factor that works for both of them that's greater than that, and that number is 20. Okay, so if you're not used to those, that can sound kind of confusing, right? But really, we're just getting used to prime factorization and then combining the numbers, figuring out which ones work for both, and then just multiplying those numbers together. And that thing I just did at the end is just a great way to check it for yourself. Okay, and then lastly, least common multiple. Okay, so let me kind of read out the definition for you at first, and then we'll go through another example here. Kind of similar though. To find the least common multiple of two numbers, so again, you'll be given two numbers. First, list the prime factors of each number. Sounds familiar, right? Then multiply each factor the greatest number of times it occurs in either number. If the same factor occurs more than once in both numbers, you multiply the factor the greatest number of times it occurs. Okay, so in this one, we're going to do 24 and 30. And try and find the least common multiple. Okay, so even if what I just read there didn't make any sense to you, just go along and hopefully we're in good shape on prime factors. Right, so we start with that. And, right, this is what the app is for, is to do a bunch of examples, right? You need practice with these things. Okay, so 24, we did that at the beginning of the video, didn't we? Okay, so that was 2 and 12, 3 and 8, and 4 and 6, right? And 2's prime, 3's prime, none of these evens are prime, 1's not prime. Okay, So that's all we got as far as the prime factors of 24 are 2 and 3. Right? You remember doing that earlier? Okay. This time we're doing it, but just applying it to least common multiple. So 2 times 15 is 30. 3 times 10 is 30. And 4, nothing works, right? 4 times 7 is 28, but 4 times 8 is 32. So 4 is not going to work out for us, but 5 and 6. 5 times 6 is 30. That will work for us. And that's all we got. Okay, so prime factors here. We got 2, we got 3, we got 5, and then 15 is odd, but doesn't work because 3 times 5 is 15. So 15 is not prime. So we got 2, 3, and 5. So 2 and 3 for 24. 2, 3, and 5 for 30, right? And so all we're going to do is combine all of those and multiply them together, right? So we have 2 times 2 whoops, sorry about that. 2 times 2. So we got 2 twice, 3 twice, 5 once. And then we just multiply those together. Right? It comes out to 120. And, or sorry. Yeah, that should be 120. Right? And then that's all we got to do. Okay, so that's least common multiple. It is very similar process, but then you're multiplying these numbers together, and it's a bigger number. So in terms of how you're thinking about it, you've got 24 and 30. This, if you want to do it in a more manual way, you can. Right? You can just say 24 and then keep multiplying it by 2. Right? Or just by a factor of 24 rather. Right? Keep going up. 72, 96, 120, right? So there's 1, and then same thing with 30. So this requires less math, but sometimes you have to go quite a ways before you find. So there it is. The 120s are the same, right? So that's another way to do least common multiple. Either is fine. This one can take longer because it can go into the few hundreds possibly, and you might be doing this for a little bit, but you just want to have two numbers that match. If you have that, then that also is perfectly fine for least common multiple. All right. Hopefully this helped you guys out.